Algebra 2 and welcome to lesson 1.6. This is where things will start to get a little more challenging as we enter everyone's favorite application problems. So, mixture and distance problems. That is the essential question. How do we solve them? So, starting off here, we're going to have to think a little bit. So, that's okay. And we're going to challenge you. And that's how you learn. How many gallons of 86% saline solution must be mixed with 10 gallons of pure water to make a 43% solution? Okay, so a lot of times when mixing things, especially if you get into nursing and such, you're going to have to dilute solutions. Okay, with mixture problems, it's always important to start out with, we have a solution and a percentage, okay? And we're multiplying, and we're going to add that to another solution in percentage, and that's a quantity, and that's going to equal some percentage, and then the addition of both of our solutions, solution 1 and plus solution 2. Okay, so let's start by highlighting some things, and this first one, there's a few little curveballs in here, so we'll get right to it. How many gallons of 86% saline solution? Saline is like a salt solution, so if anyone has contacts or things like that, that is a saline solution. So 86%, I'm also going to write percentages as a decimal, 0.86, and we just have our saline. We're going to say that's just solution 1. So SOL, we'll just save it as that. You can also say it's a variable, so we can represent it as, say, x. Okay, so solution 1 is our variable x. Must be mixed with 10 gallons of pure water. So 10 gallons is a quantity. And pure water, here's a little curveball for you. If we're referencing the amount of saline solution, pure water is actually 0%. Okay, saline. Okay, so that's a little trick there. So 0 times 10, okay, gallons, and that's going to equal, okay, 0.43. And our original solution that we're adding, we don't know, and then plus 10. So what a lot going on, but again, just take your time and recognize. So our new solution, again, is going to be 10 gallons, okay, plus whatever other solution amount we have. So that's the x plus 10. Each side needs to be balanced. Now, they won't always be a curveball here with the percentages, like how that one's a little trick of pure water. But it's a good idea to kind of just think, okay? Just use your mind. Saline solutions, pure water would have a no concentration of saline. Okay, once we set it up, and I'm going to help you with setting things up, from there, it's really just distributing and solving. So 0.86 times x, we're just going to leave it there. 0% times 10, really, that's just going to cancel out. So it's 0.86x is equal to, here's our distributive property. So 0.43 times x plus 10 times 0.43. You might not need your calculator, but if you do, that's just 4.3. And the idea is to solve for x. So minus 0.43 minus 0.43x, 0.86 minus 0.43 is equal to, hey, 0.43, and that's equal to 4.3. And we're just going to divide and divide. And 4.3 divided by 0.43 is equal to 10. So 10 is equal to x, or 10 gallons, okay, of saline solution. For these word problems, you should always get a whole number of sorts. Okay, so that's a good idea to check at the end. And again, I know it's a little confusing at first, but just remember this general formation for percentages. Percent of solution 1 plus percent of some amount 2 is equal to the combined solutions and their percent. All right, and we will get through them. You'll be fine. Alrighty, so let's use that same idea for gold, okay? How many ounces of a metal containing 4% gold must be combined with 6 ounces of a metal containing 40% gold? Now be careful with percentages again, okay? 4% gold, so ounces of metal containing 4% gold. So 4% is 0.04. And I don't know this quantity, so I'm going to let it be X. Okay? 6 ounces of 40% gold. Now 40% is 0.4. And this quantity I know is 6 ounces. Okay, and we're creating a 31%. And it's going to have whatever amount that I add in and the original amount of 6. Okay, so everything is pretty similar. Okay, again, the quantity that we're given, we're going to have to add or dilute that with another quantity. And this time, there's no real special things like 0%. Or anything like that. You do need to catch that 4% is 0.04 and 40% is 0.4. So here now, we're just going to continue to solve. Setting these up is what I think is the most challenging part. 0.4 times 6 is 2.4. And that's equal to 0.31x. Going to distribute. 6 times 0.31 is 1.86. And however you choose to solve it, just get x to one side. Now just be careful with like terms. I'm going to subtract 0.31x minus 0.31x. So 0.04 minus 0.31, and that gives me negative 0.27. Okay, x, and I'm also going to subtract 2.4, 1.86 minus 2.4, and that gives me negative 0.54. Don't be afraid when you get negatives, okay? As long as there's 2 of them, they will cancel out to become a positive. So 0.54 divided by 0.27. I know I forgot a negative, but thinking over here, negative divided by negative is a positive. That means x equals 2. It's always important to have units. So 2 ounces of the gold or metal. Okay, and again, we get that nice whole number. So great work. Again, just get used to this little setup here. So, all right, fruit punch. So sometimes our fruit punch is just a little too fruity. We want to mix it up here. So how much brand A fruit punch? 10% fruit juice. So let's see here. Okay, so how much? That's our variable. How much is some X? All right, and it's 10%. So let's just jump on in. 10% is 0.1, okay? Or you could just do 0.10. That's 10%. And we don't know, so it's going to be X, all right? Must be mixed with 8 gallons of brand B. So plus, and brand B is 50% fruit juice. So 0.50. This one I know I'm going to have 8 gallons. Okay? To create a mixture containing 42% fruit juice. So 0.42. Our unknown quantity plus the known quantity. And then it's just distributing, solving. So let's try it out. 0.1x plus 0.5 times 8 is 8 times 0.5. That's just 4, Mr. Dvorsky. Okay, that's fine. 4 is equal to 0.42x. 0.42, however, times 8, and I'm distributing here, is 3.36. And you're going to solve. So, recommendations. I'm going to subtract the 3.36. And then I'll subtract 0.1 to the other side. And 4 minus 3.36, boom, 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 0.64 is equal to 0.42 minus 0.1 is equal to 0.32. Looking pretty good, because when we divide, we get a nice number. Now, in the real world, you may not get a perfect number like this, okay? So 2 is equal to x, or 2 gallons of juice A. But for these problems, I know they're new, I know they're challenging, and I know that whole number can make you feel good. So 2 gallons of our fruit punch. Okay, and the last one here, another little curveball with this one. Peanuts, my favorite food. Peanut butter, love it. Skippy, that's the brand. I do like it all natural, but peanuts, peanut butter. Anyway, let's go. How many pounds of peanuts must Asanji add to 4 pounds of mixed nuts containing 61% peanuts to make a mixture of 88% peanuts? Okay, so how many pounds of peanuts? So this case, peanuts, that's our variable. And we're dealing with a mixture of 100%. Okay, if it's all peanuts, then it's just going to be 1. So 100% is also 1. Now, he's adding that to 4 pounds of 61% peanuts. So if you go out to the store and you look at different types of mixed nuts, there's different quantities. So 0.61 times 4, and that's our mixture. Okay, and he wants to make 88% peanuts. So 0.88, our quantity, plus the original, and that's it there. So a little bit of a curveball with thinking how much of this. So how many? Remember, that's your variable. Alrighty, so 1x plus 0.61 times 4 is 2.44. And that's equal to 0.88x plus 4 times 0.88, 3.52. Gonna subtract the 0.88. That's 0.12x. Subtract the 2.44. That's 1.08. And then we divide, we get 9. So 0.12, 0.12, x is equal to 9, and that is pounds of peanuts. Okay? So again, they can be challenging. I will help you out. Try them. Just try. That's all I'm asking. Try and see what you guys get when it comes to practice. Now, 2 more, and these are distance type problems. So some more thinking, okay? So, Willie made a trip to the town hall and back. The trip there took 5 hours, and the trip back took 2 hours. So, these problems, you might just need to take a step back and think, okay? So, Willie's walking. Typically, we know that distance is equal to rate times time. So, distance is equal to rate times time. That's just something to have in the back of your mind, okay? Now, the distance in both cases is the same. Okay, he's going to town hall and he's going back. So what we have is the trip there, or outgoing. He's traveling some rate times some for some time. Now that's equal to his incoming or return trip, I guess, return, which is equal to some rate times some time. Now the key is, what's the rate and what's the time? So the trip there took 5 hours. Okay, so that's his outgoing trip. So we don't know the rate, but we know that it took him 5 hours. The trip back, okay, he averaged 30 kilometers faster on the return trip than on the outbound trip. So on the return trip, it took 2 hours. And we know that his speed was 30 kilometers faster. So it's the rate plus 30, and he traveled for 2 hours. Okay, so a lot going on, but notice the trip there. So all this, the trip there took 5 hours. Okay, that's this, and we don't know the rate. And the trip back took 2 hours, and he averaged 30 kilometers faster. So it's the rate plus 30. Once you have it set up, it's just solving. So 5r is equal to 2r plus 60, just distributing. I'm going to subtract the 2r, so 3r is equal to 60. And that just means that the rate is equal to 20 kilometers per hour. Okay, so just thinking, rate times time, rate times time. One side has to be equal to the other side. It's just that he went a little faster. Okay. And number 6, an Air Force plane left London at the same time as a jet. So the planes flew in opposite directions. So here's an opposite direction type problem. So this plane, going this way. You can even draw a little plane. Why not? Alrighty. It is traveling at the speed of 365 miles per hour. Okay, 365 miles per hour. And after 10 hours, okay, that's how long it's traveling. So 10. Now, the other plane, a jet, or this one is actually Air Force plane. So it maybe looks a little different, but I'll still draw it pretty similar. Sure. That's fantastic. All right, so there's our Air Force plane. Now it's equal to, so after 10 hours, they were 6,900 miles, or 50 miles apart. How fast did the Air Force plane fly? So we're trying to find this guy's speed. Now, the distance apart they are is going to go here. So 6,950. And we need to subtract the speed of the plane. So after some speed, so 10 hours, and the rate. So 10 minus x. So, what's going on here? All right, well, we have the speed of the plane, the speed of the jet. Here is the distance that the plane traveled, and here's the distance in between them, okay? So, again, as you start to practice these, just set them up similarly. Again, I'm not asking you to be professionals just yet, but just to think, and again, the practice problems will be similar. So let's get through these. Minus 10x. We're going to subtract 6,950 minus 6,950. And that gives us 3,650 minus 6,950. Negative 3,300 equal to negative 10x. Don't fret because of negatives. Just going to divide by -10. And we get a nice old speed of 330 miles per hour. Again, whole number to get you there. If your brain hurts a little, that's okay, okay? It's okay to struggle with things, guys. It's no problem. The key is try your best, okay? And definitely work on the practice problems. I'm actually going to go through a bonus video of going through the practice problems. So try them. Go back, watch the bonus video if you need to. Great job. Pat yourself on the back. Learned something new today.